In this video, I will show you how to solve the inverse Laplace transform of the examples which I give you in the PowerPoint. The first example was this equation. If we have Fs equals to S over S plus 2, S plus 1. So we want to find the inverse Laplace transform of this equation. Using partial fraction, we can find an equation that has subterms which are available in the table. So this equation is equals to A over S plus 2 plus B over S plus 1, right? And this is equals to A S plus 1 plus B S plus 2. So by trial and error, we need to solve this. Okay. So this one will become this. I'll show you this ones. So this is 0, right? That will give you B equals to minus 1, right? So if we take S equals to minus 2, okay, you can try and do it yourself, right? Okay, and that will give you Fs equals to 2 over S plus 2 minus 1 over S plus 1. Okay, now we can find this term in the table and this term as well. You can find them in the table. So if you look, then you find that the inverse Laplace transform of this term is 2e to the power of minus 2t e to the power of minus t for this term. So that is the first example. The next example is this equation, Fs equals to S over S plus 2 squared times S plus 1. So to do the partial fraction, we equate this equation to A over S plus 2 plus B S plus 2 squared plus C over S plus 1. This equation is equals to A times S plus 2 S plus 1 plus B S plus 1 plus C S plus 2 squared. So by trial and error, so S is equivalent to minus 2. So minus 2 equals to, right, this term A will become 0, this term will become 0, and this term will become 0, which leaves you with B minus 2 plus 1. That will give you B equals to 2. Okay, then if you equate S equals to minus 1, then this term and this term will become 0. Then that will be minus 1 equals to C minus 1 plus, C minus 1 plus 2 squared. That will give you C equals to minus 1. Okay. And then if you equate S equals to 0, then 0 equals to, so you can replace B and C in this equation. Yeah, so you will get A sorry, a 0 plus 2, 0 plus 1, plus 2. Let me just, I think you can shorten this by just simply adding, yeah, just having this. So b is 2, so this is 1, so c is minus 1, and so you have to square. All right, that will give you a equals to 1. Okay, now when you replace all a, b and c into this equation, here, okay, so you have fs equals to a is 1 over s plus 2, b is 2 over s plus 2 squared minus 1 over s plus 1. Now, you need to refer to the table, okay, to find the inverse Laplace. So from the table, okay, you might find s plus 2, s plus 1, and for this term, it's not quite direct, so you need to look carefully. Okay, I'll just give you the answer first. This is equals to, the inverse is equals to e to the power minus 2t plus 2t e minus 2t minus e minus t. Right, if you look carefully from the theorem number, if I'm not mistaken, number 5, yeah, and 6, right, if you look carefully from the table, okay, and you need to understand the theorem as well, okay, you can see that if we have 1 over s plus a, okay, and the inverse Laplace transform is e to the power minus at, right? So then from table row 3, 1 over s squared will give you, the inverse Laplace will give you t. So which means if you have 1 over s plus a, right, s plus a squared, yeah, then you'll have t, okay, you'll have t, the squared there, e to the power of minus at, right? So that's how you get to this.